Yeah, good morning all. Now I would like to discuss about Norton's theorem. Okay, the statement of Norton's theorem is in any linear bilateral network consisting of number of sources and number of resistors are replaced by single current source in parallel with Norton's equivalent resistance in parallel with load resistance. That means complexity circuit is reduced by simple circuit. Okay, now we will see how to calculate this load current by using Norton's theorem. Okay, explanation. Okay, let us consider a circuit that is linear bilateral network. Okay, here I need to calculate current flowing through load resistance RL, right? To calculate current flowing through load resistance RL, step 1 here, remove the load resistance RL, okay, and short circuit those two terminals. Okay, here I am representing those two terminals as A and B. Okay, remove the load resistance RL and across those two terminals we need to short. Okay, after that here I need to calculate short circuited current or Norton's current. Okay, here under short circuit condition, here potential will be 0 volts. Okay, next step 2, across A and B terminals only we need to calculate Norton's equivalent resistance. Okay, while calculating Norton's equivalent resistance, if the circuit is having voltage source, that should be replaced by short circuit. If the circuit is having current source, that should be replaced by open circuit. That is about step 2. Next step 3, draw the Norton's equivalent circuit. Okay, that is Norton's current from step 1, right? Next, Norton's equivalent resistance from step 2, and the load resistance which is removed from the step 1, that will be added here. This is the Norton's equivalent circuit. Then total current ISC or IN is divided into I and IL. IL is nothing but current flowing through load resistance. Here already we know Norton's current, right? By using current division rule, we can calculate load current, right? Here already we know total current, right? That means IL is equals to total current into opposite parallel branch resistance divided by sum of parallel branch elements, that is IL is equals to IN into RN by RL plus RN. Okay, this is the procedure to calculate current flowing through any branch by using Norton's theorem. Okay, now we will solve one problem on Norton's theorem. Okay, just observe this circuit diagram. Draw the Norton's equivalent circuit, okay, across A and B terminals. That means here he is not mentioning any load value, right? That means here we need to draw the Norton's equivalent circuit which is having Norton's current and Norton's equivalent resistance. Okay, first step 1, I need to calculate Norton's current. Okay, to calculate Norton's current, what I have to do, I have to short the A and B terminals. This is 50 volts supply and resistance value is 10 ohm, 6 ohms, and another battery voltage of 10 volts. Here 3 ohms. Here I need to short this terminal, short circuit the A and B terminals. Here I need to calculate short circuited current or Norton's current, right? 10 ohm, 6 ohm, here minus plus 50 volts, 3 ohm. After redrawing the circuit diagram by using either nodal analysis or mesh analysis, we need to calculate Norton's current. Okay, nodal analysis is simpler than mesh analysis, right? First identify the number of junctions. Only one junction is present with respect to a reference node. Assume all currents are outgoing, I1, I2, I3, right? At junction V, apply KCL. Okay, then all are outgoing currents, right? I1 plus I2 plus I3 is equals to 0. Here I1 value is nothing but potential difference will be V minus 50 by 10 plus I2 value will be, here potential difference will be V minus 10 by 6 plus here V minus 0 by 3, that is equals to 0, right? If I take V as common, 1 by 10 plus 1 by 6 plus 1 by 3 that is equals to plus 1 by 3 that is equals to 50 by 10 plus 10 by 6. Okay, then the LCM will be 180, right? That is 18 plus 30 plus 60, right? Here 60 LCM, that is 5 6 56 300 plus 10 10 100, right? Then V into 108 by 180 that is equals to 400 by 60, right? 61 ja 63 ja, right? That is V is equals to 400 into 3 by 108, 3 3 ja 3 6 ja 18, right? That is 400 by 36, 4 9 ja, that is 100 by 9 volts. V value will be 100 by 9 volts. But here I need to calculate Norton's current, right? That is Norton's current IN is equals to, see here I3, both are in same direction. Norton's current IN is equals to I3, that is equals to V by 3, that is 100 by 27 amperes. Okay, after that step 2, across these two terminals I need to calculate Norton's equivalent resistance. While calculating Norton's equivalent resistance, if the circuit is having voltage source, that should be replaced by short circuit, right? The given circuit is having two voltage sources, those are replaced by short circuits. Okay, then 10 ohm, 6 ohm and 3 ohm, right? Here I need to calculate Rn, Norton's equivalent resistance. Okay, here Rn is equals to here 10 ohm in parallel with 6 ohm. Okay, these two are connected in parallel. Resultant value is in series with 3 ohm, right? Plus 3 ohm, that is 10 into 6 by 10 plus 6 plus 3, that is 60 by 16 plus 3, that is approximately 16 3s are 48, 3.7 plus 3, approximately the value will be 6.7 ohms. Next, step 3, draw the Norton's equivalent circuit, that is IN from step 1, Rn from step 2, IN is equals to 100 by 27, right? Rn value will be 6.7. Okay, suppose sometimes you may represent your load resistance, or you can leave like this also, no problem. Here unknown resistance will be load resistance RL. Okay, this is the Norton's equivalent resistance. Norton's current in parallel with Norton's equivalent resistance in parallel with load resistance. Okay, if we know this load resistance value, then only we can calculate load current. Otherwise you can simply draw the circuit like this. Okay, in this way we can calculate current flowing through any branch by using Norton's theorem. Okay, thank you all.